going to talk about the plan and document perspective on these 4 issues of performance, releases, reliability, and security. So what do you do differently, if anything, about plan and document performance? Anything special about releases? The plan and document approach is filled with standards. Is there some standards for quality, reliability? And what about security and reliability challenges any different? And is the relationship between unreliability and security? All right, so first of all, the plan and document approaches, when they talk about requirements, which is a big part of it, separates functional and non-functional. And although non-functional seems a weird word, it refers to reliability and performance, but it means functional, like adding features to rotten potatoes, and functional is like how fast or how dependable rotten potatoes are. And you can make them part of the acceptance test and plan and document. Typically, the books that talk about plan and document ignore performance. And the 2 reasons mentioned here, typically it's covered in other books, but there's kind of an allergic reaction to performance by the software engineering community because there has been a lot of bad things done to software in the names of performance, and they're kind of afraid that if you start optimizing too early, you'll screw it up, so they tend to ignore performance. Despite the fact, as Armando said, Jeff Dean says, performance is a feature. So release management is considered a special case of a grander thing called configuration management to set up your whole thing. And in plan and document, there's a lot more there than just the application itself. There's configuration files, lots of documentation. So as part of a release, you release all of these things at the same time to keep them being consistent. And then the version numbers that you've certainly seen before, but in case you hadn't thought about it, the least significant is the minor release, the middle one is a major release, and the first one, then that number changes. It's so large you probably have to report it. So it was, the latest version of Rails was 3.2.15, and as of November 1st, it's just switched to 4.0.1. So user beware of the latest Rails version. So one of the guiding lines in computer science is how do we make things dependable, and we got one trick, and it's is redundancy. And so if redundancy is the way we make things dependable, then the guideline that came up long ago, if you want to have something dependable, you can't have any single points of failure, because that'll be the Achilles heel of your system. No matter how super dependable your storage system is, if you have a flaky internet connection to get to them, your site will still be offline. So what's your weakest point? But redundancy costs money. So the question that you ask is, you want to have dependability, but how much does the customer want to pay for that redundancy? We typically measure reliability using the idea of mean time to failure. How long does it kind of stay up? Often people think of it, quoting it in terms of hardware, but in reality it has to do with the dependability of the software as well as the people working on the operators as well as the hardware. So approximately unavailability is the mean time to repair, how long does it take when something is unavailable till it's available again, divided by the mean time to failure. So interestingly, it's typically easier to measure mean time to repair and sometimes even to work on it because it's short compared to mean time to failure, which could be months or years. And in fact, Armando and I did a project together. I guess the first project we did together was called the ROC project for recovery-oriented computing, and its idea was to concentrate, making things more available by reducing the mean time to repair rather than stretching the mean time between failures, although you can work at both at the same time. So what about processes to improve software in the plan document one? So part of this kind of how come we can't make software as predictable as civil engineering, they believe part of the attack is to improve the organization. If software is not working, there's something wrong with the organization, and if we can make the organization better, it will lead to more reliable products. And part of that is recording a lot of the information that goes on. And so particular, you might have heard of an ISO 9001 standard. And there are companies, software companies will have that on, I don't know, on their building or on their products. So what does that mean, the ISO 9001 standard? First of all, this is what it looks like here, right? So you notice that official looking label on the right, committed to continuous improvement. It looks pretty good. Why does this fish company in Japan have an ISO 9001 standard? Because it's actually about quality of anything. The ISO 9001 is quality of products, not just quality of software, but in our context, we talk about software. So what do you need to do to get the standard? You have to have a quality process in place. How do you develop it? You have to have a method to ensure that your process is being followed. And then the last part is you record the results to try and improve the process. So to be a fish company or Oracle, get the 9001 standard, you have to have all 30 of those pieces. Interestingly, the product that you make doesn't have to be high quality. All you have to do is have a process that you follow, you check if it's being followed, you record the results and make improvements on your process. So it's a feedback-based system. They believe in feedback. It's going to make it better. But just because you buy software with the 9001 sticker on it doesn't necessarily mean it's great. It just means they're supposed to have an approved process. All right, what's different between reliability and security? The difference is reliability we can count on probabilities. That the amount of redundancy you need, well, what's the frequency of a failure happening? If you assume they're independent, you just need a modest spot of redundancy, but not for security, right? You have an intelligent opponent that's probing vulnerabilities. So one way to get ideas besides the pitfalls that Armando described, which is just like the worst, you shouldn't dare not do this thing, is there's a list of typical attacks. It's called Common Vulnerabilities and Exposures, Difficult Attacks, and that's the website right there, that you go get an idea of what people are doing. So was there a relationship between reliability and security? Yeah, there is. It turns out a bunch of things that lead to bugs in software are exploited by attackers. So they look for software bugs as vulnerabilities in the system. The one that everybody knows about is buffer overflows. So if you put checks in your code to make sure, or your language has checks to make sure your buffers can't overflow, then you can't have that attack. But other attacks are done on arithmetic overflows, and as you know, the world is increasingly getting parallel, so a lot of software that was developed on uniprocessors is trying to run on multiprocessors, so data races occur, and data races are another way to attack systems. So bugs can lead to attacks. One of the challenges in security versus in performance is that in performance we can run tests and see if it's working or not, how fast it is. How do you know if something is secure? So kind of the best we know today is to be able to do what are called penetration tests. You get a tiger team of experts and they try and attack your system. And how difficult was it to attack? What techniques did they use? Did you defend yourself? And that's one of the things to know. So what are some principles to try and make your system secure that you could follow? There's 3 of them. The first one's called, and this comes from our friends in the security community, the principle of least privilege. That is, a user component should be given the minimum privilege that it is. So if you've seen in movies in classified information, need to know. So you give it the least amount it needs to do to get its job. The second security principle is fail-safe defaults. You shouldn't give access to, the default should be denial of access rather than default should be giving access. So you should set up your software system and make sure the defaults are safe. And the final one is called psychological acceptability. What they learned is, besides these 2 technical issues, that if you turn the protection stuff on, it's so hard to use, people just won't use it. So it needs to be, don't create protection mechanisms that you can maintain, that don't affect the ease of use. Otherwise, people will turn it off because people don't care that much about security. Alas for my security colleagues, until they get problems.